Hello guys, welcome back to my channel Code Monger, and today we are going to solve another problem that's numbered 564. Find the closest palindrome. So let's go through the problem statement. Given a string n representing an integer, return the closest integer not including itself, which is a palindrome. So basically we will be given a number like 1, 2, 3, and we have to find out its nearest number, which is also a palindrome, and it cannot be the number itself. Okay. If there is a tie, return the smaller one. So what is meant by that? Like, let's say the number given is 100. So for it, the nearest palindrome are, let's say, 101 and 99, and both of them are equal distance. This is also one distance away, this is also one distance away, right? But the answer should be 99 and not 101. Okay, so that's what they meant by it. Yeah, that's all there is to the problem. So let's try to understand how we'll be able to solve it. Okay. Okay. So let's understand how to approach the questions of this palindromic numbers, right? How do we do that? So let's say we have been given 1, 2, 3. First thing is, like, we know what a number is, what's a palindrome, right? So if a number is like 1, 2, 2, 1, so if you read it from front and read it from back, the value is same only, right? So that's what the palindrome is. Now, for any number, in case we have to form the palindrome, how we will do it? The best approach would be to split it in half, right? And whatsoever is the, and we will split it in half, right? Left half and right half. Now, we have to find out the nearest one, right? So we will consider the left half, okay? Because we have to find the nearest number whatsoever is possible. So we will try to consider this left half and make a palindrome out of this left half. Okay, so in case I have to make a palindrome from this left half, that is 1, 2, one possible solution is 1, 2, that is the left half, and go from right side to the left side, right, in this direction. So 1, 2 would become 1, 2, 1. Okay, so that's a simple approach. Another possible solution, if we have the number 1, 2, right, I have to check out a number which is nearest, so I would subtract 1 from it, so that whatsoever is the next smaller from 1 to, right, that can also be a possibility of forming a palindrome. So if I subtract, I get 1, 1, and the palindrome would be 1, 1, 1, right? So in case of 1, 1, if I go in this direction, right, this we can ignore, and I'll try to, whatsoever is the value on here, I'll try to add it on the right side. So that's how I'll get 1, 1, 1. Similarly, let's try to add 1 in 12 also and see what we get. So when we add 1 to 12, right, we get 13, and if we create palindrome from it, it will become 131. So this is the solution. These are the three scenarios. If we simply do that, like, our solution we will be getting, right? So out of these three, what's which is the smallest or the nearest to the answer is 1 to 1, right? Rest, this is far, this is far, this is the one which is having a distance from the value only 2 difference, right? And that would be our answer. Now, are these only the three possible cases always, right? Let's try to understand that also. So there are certain edge cases to it, like let's say we have been given a number as 100. Okay, so for 100, if we try to do the way we did above, right, let's try to split it in half. So we did split it in half, right? uh, we have this left half and right half. Okay, so this would be uneven partition, right, because the number given is of 3 digit. If it would have been 1, 2, 3, 4, right, then it would have been perfectly fine to have equal halves. But in case there is an odd length number, so in that case the left half would be bigger. Okay, now let's say, as we are considering the exceptional case, 100 is given. So for 100, we will have 1, 0, right, and 1. Okay, the base case. Then if we add or we subtract 1, let's say, so we get, if we subtract 1 from 10, we get 9. 9 itself is a single digit palindrome, so that's it. Nothing else is required to be done there. If we add 1, right, to 1 to 10 basically, then we'll get 11. And to make it palindrome, we will go to the left side, we will add this 1 on that right side, so it will become 111. But let's say what's the correct answer. So based on this, if we see, right, so 101 should be our answer. But if you see, right, what is another palindrome nearest to 100? It is 99, right? But that's not covered here. So to handle this scenario also, right, we have to handle this one, correct? Now, so the correct answer would be 99 in this case, because both 101 and 99 are equal distance from 100, but 99 is smaller, so this should be a correct answer. So how we came to that, like, is 10 to the power, basically how, in case another use case that we have to create, so how we will come to this 99 as a solution. So it would be 10 to the power number of digits in the number, so that is 3 minus 1 minus 1. So it would be 10 to the power 2, that is 100, minus 1, that is 99. So this is one of the scenario that we have to also keep in mind, right? So we will get all the 99, right, where we have possible solutions of 9, 999, 99, right? All these solution would possibly be covered with this fourth case. So 3 we have already covered in the top, right? These 3, and this one is the fourth one. Now let's take another example, okay? There is one more edge cases. Let's say the number given is 999. So for this one, right, if I split it in half, okay, from here, so we have number as 99. So to make it palindrome, we have 99. We'll go to the left side. This 9 would be added to the right side. It will become 999, right? Now let's take another case by subtracting 1. So from 99 subtract 1, it will become 98, okay? And from 98, if I go in that this side and create a palindrome, it will become 989, correct? Now from 99, if I add 1 to it, right, it will become 100, okay? So from here, if I go in this direction and try to create a palindrome, it will become as 10001. And the fourth case that we just discussed above, right, that is 10 to the power number of digits minus 1, that is 10 to the power 2 minus 1, right? So it will come as 99. So that we have to add that also here, 99. Okay, now if you look at it, right, for all the possible solutions, what would be answer based on this? It should be 989, right? But that's the wrong answer, right? The nearest palindrome to 999 is 1001. Okay, so that's the thousands case. So right, so how we will write that in the code or handle this situation is 10 to the power number of digits that we have is 3 plus 1, so it would give our desired answer. Okay, so these are the 5 cases. If we are able to handle that, then these are the only possible solutions of a palindrome that a given number can have, and out of these we have to select the one which is closest to the answer. So that's all what we have to do, right? Now to be honest, like these 3 initial cases are quite intuitive, and even I was able to figure out these 3 cases. But for the remaining 2 cases of like all the 99s and all the thousands plus 1, right? These are the 2 cases that I was able to figure out from the test cases only, right? So I know it could be a little bit difficult to figure out, but that's how it is. So yeah, so if I had to summarize, right, if I have to summarize, there are basically 5 cases, right? Simply consider the left half that we have, right? Okay. Second would be the left plus 1. Third would be left minus 1. Fourth one would be all the 999s, right, that we create. And the fifth case is all the thousands, all the hundred, tens, hundred, thousands, and we have to add 1 to them. Okay. So these are the 5 test use cases basically that are there, and these are the 5 cases that will contribute to the possible palindromic solutions, right? And from them we have to find out the difference. So I hope the approach is clear to you. Now let's try to code it and see how we'll be able to write that into the code. Okay. So meanwhile, if we have, I will also try to show that into the code on the right hand side of the screen in case I write some code that is not clear, right? I will explain that on the right hand side. So keep that also in mind. Okay. So let's try to start with the code. Okay. So first we have to find out the length of the given string, right? So that would be n dot length. Okay. Then we have to find this position. Okay, so let's say we have been given in the question 1, 2, 3. So based on whether the given length is, or we could be given 1, 2, 3, 4. Okay, so based on that we have to find out from where we have to do the partition to find out the left. In case of odd, right? In case of odd, right? We have to split it from this side, but in case of even it's equally partitioned, right? So in order to do that, based on length we have to find out at from which index we have to do the partition. So let's write that code. It would be like, let's say at I index we have to partition, find from based on the length, right? Length mod 2, if it is even, right, in that case it would be len by 2 minus 1, right? But if it is odd it would be L length by 2. Okay. So here if you look, right, in this case it would be 0, 1, 2, it would be 0, 1, 2, 3. Here if we simply do, right, len by 2, right, in this case we have to do len by 2 so that we can get this 1 as index. But in case of this length by 2 we get 4 by 2, right? In case of even, so it would be 2. In that case we have to do minus 1, so that then also we get this as in left part. Okay, so I hope this use case is clear why we are doing it. And then we have to take out the left part from that partitioned string, right? So we have to partition the string also. Let's do that. So n dot substring from 0 comma I plus 1, right? So this will give us the left part of the left partition of the string. Now let's create a list of all the possible cases that will be there, from which we one of that would be our possible solution. Let's do that. So first case would be, let's create, we will have a function, right? Also what we will do in that function is to get a possible, so from to that function what we will do, will from this the left of that we have calculated, right, to that function we will send this left part. Okay, we send it 1 2, and what it will return to us is 1 to 1. It will create a palindrome for us, and in case the number is odd even, right, if we send it 1 2, it will return to us 1 2 2 1, right? So that this function should do. Assuming that we write that function, let's write all the possible cases now. If we send it left part, right, and the length is, we also send a boolean value, right, to the function. Based on that it have to evaluate, because if you see here, right, for odd it has to calculate or add the create the palindrome basically by considering this one only, right? So but in case of even, it has to consider both these two digits. So based on the number of digits in the given input, right? We have to make that decision. So that's why we have to send whether the number is of even length or odd length. So okay, that's first case. Then we'll do cases dot add. In function we will do left plus 1. So this is our second case of plus 1. Then we will do function of left minus 1 comma length. Okay, then the fourth case is actually for the 999s. Okay, so we will cast it to long because math dot power function we are using, and then 10 to the power of length minus 1 and minus 1. Okay, so it will, in our case, if the 1 to 3 is given, so it will create 99 from this case. Okay, and then the another case is of long again. Then we will do of all the possible 100 plus ones, right? So for that we will be using the complete length and adding 1 to it. Okay, so this is done. Now let's say we have all the possible cases with us, right? Now we have to find which one is the possible answer. In order to do that, we have to find its difference, the distance from the original number, and see which one is the nearest, right? So for that we'll be needing, let's create a long variable of difference, which is actually its distance, right, from the given value. Okay, then there would be the original number, right, and then we will have answer. For now let's initialize it with minus 1. Okay, now let's consider all the cases one by one, all the cases that we have. If the given value is equal, if the current case, right, basically what's the current scenario, that is equals to the number, then we have to just ignore it, right, because in the problem set it cannot be the answer. Then if, let's check the difference, right, between the given value and the original number. If it is less than the difference, then we find a potential answer, right? So that is our potential answer. But other than that also, right, we have to update the difference also. Now the difference would also change, because this difference is actually used to calculate the nearest value. Now there is a scenario, right, as we discussed, when we have 100. For 100 we have 101 and 99. In this case, if you look, right, the difference for both of them would be same, and if we don't handle that condition, we will miss 99. So for that, even if, let's say, the difference is same, right, if the difference is same, we have to check the minimum value. Okay, the difference between the value and number is same, right? In that case, our answer would actually be the minimum value of answer and the current value that we are processing. Okay, so that's the use case. Once that is done, right, once that is done, only thing is we just have to return this answer, and it should be in string format. So let's convert that also. Now this part is clear. Now we have to write this function. So what we discussed is that this function is responsible for creating a palindrome for us. Okay, so let's do that. It will receive the left part, right, and a boolean to tell whether it is an even or not. Okay, now let's store this into the result. Because why we are doing it, because if it is like even, if it is odd, right, let's say if it is odd, in that case we have to divide it by 10, Why we are doing it? Because as I discussed here, right? So for 1 2 3, the left part would be 1 2. Now to make it palindrome, we have to remove this 2 and add this 1 to this 12, right? And it will become 1 to 1. To do that, we have to remove this 2. So to do that, whatever the left value we are getting, we have to divide it by 10 only if it is an odd number. In case, let's say it is something like 1 2 2 1, sorry, 1 2 3 4. In this case, the left part would be 1 2, right? So from 1 2, we have to consider both 1 2, right, in order to make the palindrome. So we won't remove this 2 and it would become 2 1. So only in case of odd one we have to divide it by 10, right? Now let's write the remaining code. While left is greater than 0, right, we have to update our result. So it would be result multiplied by 10 plus left mod 10, and left divide is equals to 10. Okay, and then we simply have to return the result. So this function will create a palindrome for us and return it, and we will add this in the cases, and then for all the cases we will calculate the one which are having the minimum difference, right? And whatsoever is the possible solution, we will return that. So let's try to run it. Hopefully it should run. No minor mistakes are there. Okay, yeah, we missed a semicolon here. Let's try to run again. Right, so the basic test cases are working fine. Let's try to submit the solution and see how is the performance. Okay, so this works fine, right? It beats 81% of the solution. Okay, let's try to submit again. Sometimes that happens in Leetcode, like the performance is, yeah, as you can see, right? After the second run, now it's saying 2 milliseconds to run with the 97.99%, beating the remaining solution. So yeah guys, that was all about this problem. So hope you are able to understand the approach that's being taken to solve this problem. So do subscribe to my channel for more content like this. In this channel I discuss the daily problems on the Leetcode. Other than that, there are playlists also on this channel that contains various uh, topics that's being covered, right? So do subscribe to my channel. See you in the next video.